Hello everyone, this is Mr. Underkoffler. Today we're looking at the guided notes called Solving Equations That Have Like Terms. Alright, as you guys probably recall from earlier this school year, like terms are terms that have the exact same variables. However, they also can be terms with each having no variable at all, therefore just being numbers. Now, solving equations that have like terms. Problem number one. Notice these are not like terms. 3 has the m, but 6 does not. So what do? We just do inverse operations. Inverse of adding is subtracting. Inverse of multiplying is dividing. We do reverse order from order of operations. So instead of PEMDAS, we will do it backwards, which is SADMAP. This is normal type of equations you guys have solved many times. But take a look at number 2, a little bit different here. Here we have x, 4x, 12x. Notice all three terms have x. Therefore, all three of them are like terms. And it just so happens that x is the same as 1x. So what we can do is we can add these like terms together. 1x plus 4x is 5x plus 12x is 17x. And then there's only one inverse operation to do. Inverse of multiplying is dividing, not a big deal. And we get our answer for x right away. Now, why did we not do this in number 1? Because the 6 did not have an m, but the 3 did have an m. So they were not like terms, therefore we could not add them together at all. Which brings us to problem number 3. Now this one's a little bit different. Notice 5 is the only term that has a variable. 27 and 48 both have no variable at all. So those two constants, which is what they're officially called, are like terms. They both have no variable at all. So we will add those like terms together, but we will not add it to 5n because they are not like terms together. So what do? We finish this problem the same way we basically solved problem number 1, where we do the inverse of adding, which is subtracting, and then later the inverse of multiplication is dividing, and that will give us the answer for n. All right, I would like for you to try number 4, 5, and 6 on your own. You're going to have to figure out, are these problems where there's like terms? Are they all like terms, like problem number 2? Are just maybe a couple of them like terms, like problem number 3? Are none of them like terms, like problem number 1? So try 4, 5, and 6 on your own. Hit pause right now on the video, and then hit play when you're ready to see how you did. Okay, have you already done 4, 5, and 6 on your own? If not, you better hit pause now because I'm about to go over this. All right, problem number 4. All three of them had an n, so all three of them are like terms. The one that doesn't have a coefficient that you can see has a coefficient of 1. In case you forgot what I mean by coefficient, I mean the number that is multiplied to the variable. All right, so 9n and 1n is 10n plus 25n is 35n. And now there's only one thing happening to the variable. It's being multiplied. Inverse is to divide. And you'll use your calculator. And 945 divided by 35 gives you a whole number of 27. Problem number 5. Are they like terms? No, they are not. Not at all. 8 has a w. 29 does not. So we're going to have to do inverse operations in the reverse order of what's happening to the variable. The variable is first being multiplied by 8, then it is being added by 29. So let's do the opposite order of that. Let's subtract by 29 because the inverse of adding is subtracting. Do it on both sides. This is going to give you 8w by itself. Right side gives you 2.5. Inverse of multiplying by 8 is dividing by 8. This is going to give you 0 point something. Whenever you have a smaller number divided by a bigger number, you are going to get 0 point something. Do not divide in the reverse order. Please do not think the bigger number always gets typed in first. That is not always true. Whatever number is on top gets typed in first into your calculator. Whatever number is to the right of the division symbol stays to the right of the division symbol when you type this into your calculator. And you're going to get 0.3125, also known as 5/16. There are some calculators that will give the fraction answer of the version instead of the decimal version. I would accept the fraction version. And finally, problem number 6. There were 2 like terms, and that was the 16x and the 4x. They both had x. 18 does not have x. So add your like terms together, you get 20x. And then you're going to have to solve this the same way we solved Problem number, which one was it? Was it number 5, where there's two things happening. The variable is being multiplied and then added. Inverse of adding is subtracting. That's going to give you 972. Inverse of multiplying by 20 is dividing by 20, and that's going to give you 48.6. If you messed up in your work for any of these 3 problems, feel free to rewind the video to the problem that you need to see. Feel free to hit pause. If you need to fix your work, do what you got to do. Okay, we're going to finish this small little lesson with 2 more problems, and this time we're going to change it up just a little bit. And I even gave a subtitle for this, when there's 2 sets of like terms and there's also subtraction. So, do you see what I see? We have 6x and 4x. They both have x. They are both like terms. But we also have constants that are like terms. The 21 has no x. The 36 has no x. But unlike what I did on numbers 1 through 6, this time I threw a curveball. I put subtraction to the left of this 36. So what do we do with that? Well, ladies and gentlemen, you all know subtraction is the same as adding the opposite. Yes, you should do that before you try to combine like terms. Because if you do not do that, you're going to be fooled into thinking that this is going to give you 21 and positive 36 and give you 57, and it is so not going to give you 57 because the minus to the left of the 36 is the same as having a negative 36, as you can now see by making subtraction become adding the opposite. So do that right now with your pencil if you haven't already. And now let's add our like terms together. 6x and 4x, they are going to give you 10x. Go ahead and write that down. 21 and negative 36, as you can now see. Subtract in your head, giving you 15. Who has the bigger absolute value? It is the negative number, so it's negative 15. And then obviously 72 is still 72. Go ahead and write that down. Now let's do inverse operations in the reverse order of what's happening to x. X is being times by 10 and then added by negative 15. You can subtract by the negative, but I think you guys know by now, subtracting a negative is the same as adding a positive. And after all, to get 0, you would have to take a positive 15 to add to the original negative 15. So I'm actually really fine if you guys just make it adding positive 15 right away. I mean, that is the quicker, smarter way of tackling this problem instead of wasting your time making it minus a negative. I mean, yes, the inverse of adding is subtracting, but when you subtract a negative, you will add a positive. That way you will get 0. So you might as well just make it adding a positive right away. Okay, now that I've said all that, what do we get? Well, 72 plus 15 is 87. Negative 15 and positive 15 gives you 0, so that's gone. We now have 10x. Inverse of multiplying by 10 is dividing by 10. I hope you're writing this down. And that's going to give you 8.7. Okay, now that we have done number 7 together, why don't you try one very similar to it, and it is problem number 8. Hopefully you can see where the subtraction is. Don't forget to make it adding the opposite. That's all I'm going to say for now. Hit pause, do number 8 on your own, and then hit play when you're ready to see how you did. Okay, did you already do problem number 8? If not, you better hit pause now. Because here I go. First thing you should do is make subtraction become adding the opposite. If you did not do that, then you probably did not get 9. You probably thought it was a positive 21 and a positive 30, giving you 51. Nope, it's not going to. A negative and a positive, subtract in your head. And the bigger absolute value this time was the positive 30. So this is positive 9. 19x and 5x gives you 24x. From here, inverse operations, get rid of the adding by subtracting. 180 minus 9 is 171. And then the inverse of multiplying by 27, or sorry, did I say 27? The inverse of multiplying by 24 is dividing by 24. And this is going to give you a decimal, not a big deal, 7.125. This is also the mixed number of 7 1/8 for those of you who prefer a mixed number. I would accept it either way. And that concludes this short little lesson on solving equations that have like terms. Thanks for watching. We'll see you next time.